Good morning, boys and girls, and welcome back to another day of calculus. And today we're going to cover 5.7, integration of inverse trigonometric functions. Couple things there. If you're looking in our book, this section is not in our book, so just be aware we're covering this from our old book. So there'll be a separate spot, so don't look for this in the new book. It doesn't do a very good job of covering it. All right? So with that being said, here are the three inverse trigonometric functions that you need to be able to integrate. Okay, arcsine, arctan, and arcsecant. Again, it's a lot of memorizing of the different formulas here. If you look and you kind of think back to yesterday's lesson on the derivative of inverse functions and derivative of inverse trigonometric functions, you're going to see a lot of similarities. Okay, the derivative of arcsine was 1 over the square root of 1 squared minus x squared. So we kind of see that form right there. Okay, the derivative of tan inverse or arctan. And by the way, let's check this out real fast. Arctan and tan inverse. These are the same thing, different notations, but they mean the same thing. And we use them interchangeably. Sometimes the little negative one kind of gets confusing, so that's when we start to say like arcsine and arctan. But the derivative of arctan was 1 over 1 squared plus x squared. So again, we kind of have that same format here. All right? So if you know your derivatives of your trigonometric functions, your inverse trigonometric functions, then I think it helps to do the integration of them as well. And then the other thing I'll point out here as we're looking at this is that we really just need to know these three. You're not going to have no arc cosine or arc cotangent or arc cosecant. But as we go down here, the other thing I kind of keep in mind to help me to remember when I get that formula is that they continually kind of add stuff. The first one was just arcsine of u over a. Then was arctan of u over a, but you add a 1 over a in front. And then the third was arcsecant of u over a with a 1 over a in front. But then you have to add the absolute value. So I kind of use that to help me memorize these formulas on how to do each one once I have them identified. All right? But bottom line, we want to get these down and kind of know them well. All right, let's do some examples with these. All right, so here's our first example. And just in the big scheme of things, when you're doing these, the real challenge kind of comes in. We're just going to start getting a bunch of different types of integration problems now, like we've talked about. And, I think the first trick is, how am I going to integrate this? You kind of got to wrap your head around that. And so I would say, just generally speaking, first you're going to try to use reverse power rule if you can. In this case, again, because it's, inside of something. Obviously, we can't. The second thing I would say you're going to try, generally speaking, is u sub. And so, like in this case here, you might try u sub. U is 1 minus 4x squared. And then, du would be negative 8x dx. But you're going to quickly see that we don't have the tools to make u sub work here. We got that extra x in there. If I try to make the u match it, I can't. U sub falls apart if you play around with this relatively quickly. All right. So when that happens, if you can't use power rule and you can't use u sub, then I want our minds going to some of these other integration techniques, integration methods. And what kind of tips me off here that I need to use an inverse trig function is when we have perfect squares. If we glance back here, you note this. For all these inverse trig functions, perfect square, perfect square, perfect square, perfect square, perfect square, we have a bunch of perfect squares. So if you see perfect squares, like 1 and 4, that might help to tip you off that this is an inverse trig function. All right? So now that I know that it's an inverse trig function, what I'm going to want to do is I want to put it into that form. I'm going to want to make it match one of these. All right? And now you got to figure out which one it is. If it doesn't have square roots, that is generally an arctan. Okay? If you have a square root, then you know it's either arcsine or arcsecant. And arcsecant, again, generally has something out in front of it. All right? So in this case here, because I have a square root with nothing out in front, I'm thinking this is my arcsine one. So I'm going to write that down. All right, so here was our rule for arcsine. If you had the integral of du, or 1 over the square root of a squared minus u squared, that is the arcsine of u over a plus c. All right, so I want to kind of try to make it look like that. So in this case here, I think the first thing I would do is I could pull that 3 out in the very front. So there's just the 1 or the dx on top. I need an a squared in front, so I'm going to call, a is equal to 1. So then 1 squared is 1, so I can rewrite this as a squared minus, and then I'm going to say that u is 2x. If I square 2x, that quantity, I get 4x squared. So I can rewrite those two things. The only thing I need to make match now is this dx at the end. And so just like we did with u sub, if I go take the derivative of u, I get 2x, or I get 2 dx. And again, I gotta watch my work. I'm gonna try to keep it nice and neat for you guys. All right? Move this to the side a little bit. du equals 2 dx, so it doesn't get mixed in with our work over here. Take this 3, move a little bit closer. All right? So now I know that dx, du over 2, would equal dx. Okay? So we can come back here and I can put du, and I can bring that over 2, out to the very front. And so now I've got it in our right form. All right? So once we do that, then we can go ahead and integrate. The 3/2 stays in front. I now know it's arc sine of u over a plus c. My u, we said, is 2x, over a is 1, plus c. Or this would be 3/2. Again, arc sine or sine inverse. You could use either notation. I'm going to switch it up so that we get used to both. And so my answer would be 3/2 arc sine of 2x plus c, or 3/2 sine inverse of 2x plus c. And that is how this problem would integrate right here. All right? But we're just going to kind of do some u sub similar stuff. All right, let's do another one. Okay, so on this problem here again, we would be thinking, just regular integration, can't do it, power rule. I might try some u sub, doesn't work. So again, I'm seeing some perfect squares. X to the 4th is a perfect square. 4 is a perfect square. So again, gets my kind of, inverse trig function, integration kind of going. All right. So to do this again, I want to try to make it match the right form. Because there's an x, there's stuff outside of the radical, I'm thinking this is arc secant. I'm going to write that one down now again so we can look at it. Okay, there we go. So I need it in this form. I need like 1 over u squared root u squared minus a squared. And then once I have in that form, I know I can use this formula that it's 1 over a in arc sine, absolute value of u, plus a, plus c. And again, all these, don't forget your plus c. Which is making me think, now, did I forget my plus c on the last one? Nope, I got it. But all indefinite integrals, make sure you put plus c. Okay? Always and forever. All right, so now I got to make it match that form. So again, I start with the easier stuff. Okay, I'm going to want my u to be x squared, because x squared squared is x to the 4th. And I'm going to want my a to be 2, because 2 squared is 4. All right, so I kind of got the inside of the radical taken care of. I got to go deal with that dx thing. So du is 2x dx. All right, we're having some issues here trying to make it match that form just a little bit. If you look here, we have the integral, right? 1 over, I've got the square root, I've got u squared, and I've got a squared, but I don't have, and I messed up here. It's not u squared on the outside, it's just u on the outside. Gee, what happened to all that? I don't have the u on the outside here. Okay, we just have an x, but I don't have an x squared on the outside. And I don't have like an x dx. I've got an x on the bottom, but not an x on the top. Where it's just a little bit off. Okay, so here's how we're going to fix this one. Here's the trick that you got to use sometimes. Is if you have a fraction, you can multiply the top and the bottom by the same thing. All right? Multiply the top by x in this case and the bottom by x. If I'm multiplying by the same thing, I'm really just multiplying by 1. X over x, x divided by x is 1. All right? And so now if I do that, this really becomes the integral of x over x squared root x to the 4th minus 4 dx. And now we're having a lot of the things that we need here. I've got an x dx for my du. I've got an x squared, which is my u on the bottom here. So that is now kind of working out a little bit. The only thing I don't have is this 2. But like we did before, I can divide by 2 so that du over 2 is equal to x dx. All right? So now this x dx right here becomes du, and I have a 1/2 out in front because du over 2. And then this x squared just becomes a u, and now we're in our correct form. But you really want to work on setting up this u sub. I think it makes this integration way easier. Now, once you get there, all right, 1/2 from the 1/2 in front, and now I can roll through my formula, times 1 over a again was 2, arcsecant of the absolute value of u, absolute value of x squared, over a plus c. And now technically I would distribute that 1/2 times everything. So I get 1/4 arcsecant, again is the same as secant inverse, just to change up the notation. X squared is always going to be positive in this case, so you could drop it over 2 plus, and again 1/2 times c is still just c. So that would be my antiderivative. 1/4 arcsecant x squared over 2 plus c. And if you're ever unsure, you could go and take the derivative of that, and it should give you the same thing that's on the inside right there. All right, one more and we're done. All right, I'm warning you, I'm going to get a little feisty with you on this one. All right, so if you're looking at this, again, first thing I'd be thinking is, all right, let's try u sub. U sub doesn't work. Or regular integration, then u sub, that didn't work. Then I'm thinking I see perfect squares. Hey, that looks like, a trig function. Inverse. However, again, that didn't have the 4x plus 3 on top. All right? So sometimes we might have to do a little bit of everything. And so what I'm going to do here is I'm going to split it up first. I could take this fraction and using our integration properties, I could split it up like this and put it as 4x over root 1 minus x squared plus 3 over the root 1 minus x squared. Okay? And again, now if you're looking at these two integrals, you're like, well, that's not much better. But I do this example part to show that how similar different types of integrations can look. The one on the left now, if I'm going to go do this one, because of the x on top, is going to be just a regular u sub integration. The one on the right, because there's no x on top, is an inverse trig function, very similar to the first problem that we did. All right? So you kind of got to be careful, and it's going to take some time of playing around with these two things, but now I'll walk you through integrating both pieces of this. Okay, so for this one on the left, I made u equal to 1 minus x squared because it's on the inside. That made du negative 2x dx. I have a 4x dx, so to make that match, I multiplied both sides by negative 2. So I got negative 2 du equals 4x dx. All right, so now we could go and integrate this side. The negative 2 would come out in front. This becomes 1 over root u du, and now I can integrate this just like normal. Okay, so continuing on with this integration, I rewrote that as u to the negative 1/2. Then I integrated it, added 1 using the inverse, the opposite power rule, inverse power rule, divide by the new exponent, and then so we get negative 4 u to the 1/2. Again, technically I should have plus c, but because I'm going to get plus c on all these things, you can just do the 1 plus c at the very end. And so that's why I kind of held up on plus c, but I did think about the plus c. And then so for this first part, I get negative 4 root 1 minus x squared when I plug back in for my u. All right? Now I've got to integrate this other one over here. We said this is our arc sine one, so I'm going to try to make it match that form. So I'm going to pull out a 3 as the very first thing I'm going to do. Then I'm going to find my a and u. So a is 1 and u is x. So du is dx. And now I can rewrite. So we get plus 3 integral 1 over the square root of a squared minus u squared du. And then when I integrate that, that is 3 sine inverse of u over a plus c. Or plus 3 sine inverse, or again, arc sine of u is x, a is 1, plus c. Or our complete answer now, if you put both pieces together, is going to be negative 4 root 1 minus x squared plus 3 arc sine of x plus c. And so, again, two very similar integrals, two very different integrations. So be careful, but that's how we have to pay attention. And that's how we take a nice little problem like that and make it lots of fun. All right, see you later, boys and girls.